Okay, first we need to get started with AWS IoT. Open this IoT core and select manage, and we can connect our device. Okay, here is now next. And we need to create a new thing, and we can name it Android 4. Next. And then we need to select our platform operating systems. We select Linux and Python as our device SDK, and then select next. We need to download this connection key so that our Android device can connect to AWS. Can use this file download. Next. And after that, we need to run this command on our Android device so we can connect them to our AWS. I will show in pictures. You can see in the dock. Okay. Now we can also view all our things created here. And next, we need to go to Dynamo. Next, we need to set up rules for our DynamicDB here. Message routing rules. We need to create rules to activate Lambda function. Create rules. Let's give it a name like Wi-Fi signal to Lambda. Next, we can use SQL statement to. Okay, here we select everything from Wi-Fi signal strength. Okay, then we next, and we need an action here. Function store Wi-Fi data, and that's all. Yes, and then we can create. And now our rules is created, and then we need to create DynamicDB. Okay, here let's create a table. Which name we can give it the name Wi-Fi signal data 1. Okay, device ID is our partition key. It's a string. And sort key, we can use our timestamp so we can sort it as our time passed. Okay, or other we left default is create table. As you can see, we create a dynamic table, and then we go to Lambda function so we can add how the data can be transformed and how we can use the data. You can see here we add a trigger here, and we add trigger AWS LOT, and we set the rules is our select rules query statement Wi-Fi signal strength. And all this is the setup in AWS, and what the detailed code you can see in the doc. Thanks.
For now, I will introduce how to use the Raspberry Pi to do our data collection. stage. And also we saw another problem about how to use the Raspberry Pi to connect with our Android mobile. And for the first one, we write a Python code to do the data collection, which we use in the Wi-Fi RSSI signal strength collection to do some to collect the Wi-Fi data. Uh, and this Python code is designed to using the Raspberry Pi to do some built-in Wi-Fi module, and it utilizes the iwconfig command, which is commonly available on Linux system, and to obtain the signal strength level in dBm. And for this function, get Wi-Fi signal strength, executes the command iwconfigure a wide LAN 0 to retrieval the information about the Wi-Fi connection on this interface, and the output of the will be processed to extract the signal strength level in dBm using the regular expression, and it search for the pattern like signal level, this pattern, and if the signal strength is not found, then returns to the value, and for the main loop, the program enters in a loop like to collect and print the Wi-Fi signal strength, and for like every 5 minutes, 5 seconds, it calls with the function to retrieval the signal strength and print to the console in dBm, and if the signal strength can't be obtained, it prints a message indicating the failure. And yeah, this is the how we use the Python to do the data collection of the Wi-Fi signal, and then we try different methods to use Raspberry Pi to connect with our Android phone. And first, we need to answer why we need to use Raspberry Pi to connect with our Android phone. Because we need the Android phone to using the SSH client, such as the Termux we used before, and we can access the Raspberry Pi's terminal directly from our mobile, and allows us to run commands and also update the system and manage some files, or also help us to develop the backend APIs, and to do some our dashboard for the following part. And we have 3 methods to connect the Android phones. We use the wired USB, and we can use the Wi-Fi hotspot, and also the Bluetooth, and considering about the signal stability, and finally we choose the USB to connect the Raspberry Pi with our Android phone. Yeah.
Hi. So this is my part of the presentation. Basically, essentially, I'm doing the website. You know, I've already got everything configured. Basically, as you can see here, this is locally because I have some deployment issues with the GitHub, but right now it works locally. Connecting to server, receive the dot, going back. This is still the basically the website is still in the development phase. Since we're still trying to figure out the AWS and the whole workflow, essentially I already have the code to connect to AWS and pull, you know, all the locations from the server. It's just that a matter of getting that part settled, and then I can just put this into this, which is what I currently have. Uh, Essentially, I have this listener that's going on here. Render listen for updates. Basically, this showing connecting message, and after that, uh, we just got this, um, which is essentially just the whole AWS thing. I just gotta copy all of that to this, and once the server is all figured out, since I already got our data collected, it's just a matter of time of I can pull update from the server like in real time from my website. Here. So this is the default dot we have, but it's gonna be changing after the whole workflow is connected. That's pretty much it. Having some issues deploying the website. I just don't know why. Right now, basically, this is the local one, and like it just tells me the server like it responded with the status of 404. Basically, they cannot find the script, which I already have uploaded the script. So I don't know why that is a problem, but essentially everything else works. Just waiting for it to connect to the server and fetch the data updates through essentially this, and then we just have essentially, where is it? Yeah, here. We just have to fetch it like every time. Basically, just listening for updates again and again. Basically, and then plot it here. So yeah, my part is pretty much done.